Okay, today what we're going to talk about is the line of best fit. The couple of things that we need to remember before we go into line of best fit is some eighth grade recall, as well as some new things that we're going to be dealing with. So first and foremost, we want to remember our slope-intercept form, y equals mx plus b. Y is the dependent variable. We need to recall that. M is our slope, and x is the independent variable, and b, of course, is the y-intercept. So the individual data points in a scatter plot form data clouds. That helps us determine what type of trend that we're dealing with. The line of best fit divides the data into two equal parts, and there are three possible relationships. And a correlation coefficient is a mathematical tool used to describe the strength of the relationship. All right, so for a positive correlation, the correlation coefficient is going to be close to 1. In a negative relationship, the correlation coefficient, the closer to -1 it is, the stronger the negative correlation. And no correlation, the closer to 0 that the correlation coefficient is. Now, trend lines. We dealt with trend lines in 8th grade math last year. And what a trend line is basically you have your scatter plot, and then you drew a trend line and tried to make predictions based upon that. What we're going to do now is I'm looking at this graph here on the next page, and I'm not going to go ahead and draw a trend line and guess where it should be. Instead, what I'm going to do is I'm going to go ahead and do some math to figure it out. So it says use points 2, 21.75 and 421 to write slope-intercept form of an equation for line of best fit. I'm looking at A right now. You can see I have a graph that's talking about the consumption of gallons based upon the year since 2000. So first thing I'm going to do is I'm going to go ahead and determine my slope. So 21 minus 21.75 all over 4 minus 2. That's going to equal negative 0.75 over 2. That's my slope. So now I want to go ahead and go to point slope form. So I have y minus y1 equals m times x minus x1. So y minus 21 equals negative 0.75 over 2 times the quantity x minus 4. Now I'm going to leave that y minus 21. I want to go ahead and distribute negative 0.75 over 2. So I have negative 0.75 over 2 plus 1.5. So now I go ahead and what I'm going to do is I'm going to add 21 to both sides. So y is going to equal, and I'm going to change this to decimal form, negative 0.375x plus 22.5. Okay, there is my slope-intercept equation right there. Now it says predict the milk consumption in 2020. If I do that, then x is going to have to be, because look, years is on the x-axis, so that's my independent variable. So x is going to have to equal 20. And if I substitute, oops, I'm sorry, I'm on C there. If on B, x equals 20. If I substitute 20 into this equation right here, my answer will end up being 15. Go ahead and check my math and make sure I'm doing the right thing. Next, it says predict in what year milk consumption will be 10 gallons. So now I have that 10, And 10 now is going to be substituted in and become y. Okay, gallons is on my y-axis. So if I substitute that in and I do all the math, I'm going to have y equaling 30.3 repeating. If I substitute that in, I'll get 30.3 repeating. Since it says years since 2000, that means my answer then is going to be 2030 for answer C. Okay, this is for answer C. And then is it reasonable to use the equation to estimate the consumption of milk for any year? And I would most certainly say yes. There is a direct correlation between the years since 2000 and the consumption of gallons. Okay, now you have this table of values down here at the bottom. Let's go ahead and say our years are our X values, and let's say the vertical drop in feet are our Y values. Go ahead and switch to the next page. We're going to use this data. Okay, I want you to use this data and enter it into your graphing calculator. Okay, go ahead and follow all of the instructions that you have here. I even told you once you go ahead and do this, what your Y, your A, your B, and your R2 and your R squared and your R should end up looking like. Now, if you want to get these two values, okay, your diagnostics have to be turned on. Okay, your diagnostics have to be turned on. If you don't know how to find diagnostics, it's okay. We'll talk about it in class. To be honest with you, I went to the catalog feature, found diagnostics, and turned it on that way. Okay, finally, on step 3, all right, you need to go ahead and graph the information. Make sure you adjust your window. Okay, because we're only dealing with positive values. We really don't need negative X or Y values on this graph. And then go ahead and give a sketch of what your graph will look like. Thank you.